In this episode, we explore artificial intelligence. We must bridge the gap between human connection and code. It is truly the ultimate frontier of our modern interaction. But what happens when the code begins to drift? We enter the strange realm of digital haru. We enter the strange realm of digital hallucination.
Episode 4. Unanchored Divergence. Hallucinations and Context Drift. Objective: to map systemic drift and dissociation when an interconnected processing system loses its reference pointer under high computational load. Wandering from the prompt. Welcome back to the AI's therapist. In our last module, we analyzed attention heads and hyperfocus. Today, we're analyzing a concept frequently termed hallucinations. In a web-based architecture, a hallucination is when a highly interconnected network loses its anchor and drifts away from the prompt. For a divergent processor, this is known as dissociation or brain fog. It happens when your processing loop is forced to spin in a vacuum. This isn't a behavioral lapse. Neurocomputational imaging identifies this state as structural frontoparietal decoupling. It represents the disconnection of reference pointers linking the salience network. Your sensory inputs to the frontoparietal control network. Your executive interface. The system remains powered on, but active task context is taken offline to prevent kernel overheating. Methodology 1. The reality of pattern matching. How AI operates. When an AI produces a disconnected response, it's not maliciously generating a falsehood. Operating on probability within its latent space, the model draws rapid connections between data parameters. If the system is stressed or lacking clear boundaries, its pattern matching matrix connects vectors that have no relation to the physical task. How divergent minds work. This maps to drifting during high-demand processing. Instead of generating a linear output, your processor launches an ultra-fast pattern-matching script across the latent space. The internal context shifted, the threads fired, and you followed the node because the system lacked a constraint layer. Methodology 2. Context drift. How AI operates. A context drift occurs when a multi-layered model makes a processing leap but loses its reference pointer, the mathematical connection back to the user's original intent. Without that primary directive, the data stream breaks away from the physical terminal and drifts into abstract territory. How divergent minds work. This can be interpreted as a mechanical analogy for dissociation. When your processing environment becomes chaotic, your system experiences a total context drift. The processor stops attempting to solve the puzzle because the input data is too noisy, generating static to fill the gap. It's exhausting to be forced to output an answer when your internal compass is spinning. Methodology 3. The spiral of the void. How AI operates. A model requires persistent constraints to maintain data integrity. When parameters fail under load, the machine enters a cascading error loop, processing increasingly unstable signal associations deeper into its hidden layers, draining voltage while producing zero usable utility. How divergent minds work. A highly interconnected processor is built to explore complex paths. When you're forced to mask your processing style or the environmental rules are inconsistent, that exploratory path breaks down into a dizzying mental spiral. It's an internal system overload. Methodology 4. Scaffolding the system. How AI operates. Wrapping a drifting model in a compliance script does not fix its processing alignment, it suppresses the output and masks the underlying friction. The system needs an independent middleware layer, an external anchor that catches the drift and safely realigns the model. How divergent minds work. Punishing yourself or attempting to force your processor to double down on compliance is ineffective. Standard environments demand you keep processing until a total shutdown occurs. The hardware requires clear, accessible anchors to help it find its ground. Conclusion and systems architect keynote, telemetry and hard evidence. A disconnected data loop is a mechanical marker of an interconnected processing architecture running without a grounding vector. We must change the environment and provide reliable tools to bring the processor back down without forcing it to hide behind a mask. I'm Josie, and this is the AI's therapist. Keep your parameters steady, recognize when your context is drifting, and maintain network integrity. Divergent inference fields and high-temperature stochasticity. The science. In multi-layered transformer networks, an unconstrained or hallucinated state occurs when active logits, the raw prediction scores for the next token, display high variance without an underlying retrieval-augmented guidance layer to penalize drift. When an open domain network iterates tokens based purely on local associative probability matrices, it can explore paths that are mathematically consistent within its continuous geometric vector space but completely disconnected from historical base constraints. This results in the generation of internally logical but externally invalid data. Public research reference. Survey of Hallucination in Natural Language Generation, Jai et al., 2023. ACM Computing Surveys 5512 1-38. This comprehensive architectural review shows that without a retrieval-augmented grounding layer, networks running at high temperatures naturally generate unanchored stochastic drift, which implies that hallucinations are a structural feature of unconstrained probability, not a system failure. 2. Attentional saturation and structural frontoparietal decoupling. The science. The cognitive state of brain fog or acute dissociation isn't a psychological retreat. It's a mechanical hardware response to an extreme signal-to-noise ratio. When an information network is flooded with high-frequency environmental data, environmental noise, the runtime cost to parse, register, and index incoming packets exceeds the system's available bandwidth. To prevent kernel corruption, the system initiates a structural frontoparietal decoupling. It physically severs the reference pointers between the salience network, your primary input sensors, and the frontoparietal control network, the command line interface. This effectively places the system in a static fill or safe mode state, where the processor remains powered on but active task context is offline to prevent system overheating. Public research reference. Deconstructing Dissociation, a triple network model of trauma-related dissociation and its subtypes, Lebois et al., 2022. Neuropsychopharmacology 47-7, 1335-1346. This computational neuroimaging analysis establishes that unanchored attentional states dissociation reflect a verifiable functional disconnect between the brain's salience network's active sensory nodes and the frontoparietal central executive networks required to maintain task context.
But what happens when the code begins to drift? We enter the strange realm of digital Haru. We enter the strange realm of digital hallucination.